Hello guys, in this video I would like to explain about climatic streams and then what data format we need to calculate these climatic stream in R, and in the end I will explain that how we can calculate these climatic stream in R or R Studio. So first of all I would like to talk about extreme. What is mean by extreme? Extreme is some phenomena which is far away from normal, or you can say from average conditions. Like if we talk about temperature, this means that if in a particular region's temperatures, like in the South Asian countries, temperature is 45 or 50 degrees centigrade, that's considered as an extreme, upper extreme. And in the lower case, if it is in some part is of course negative, the Himalayan region, but in the plain areas, if it is reached -5 or 0 or -5, something like this, we can say that is extreme. So this is something like relative terms, and you can define like which is away from normality, from normal conditions. Similarly, we have climate extreme, temperature extreme, and precipitation extremes. So first of all, we need to understand these climatic stream, their definition, their units, and then we will calculate, because if you don't know about these, the units of this climatic stream, then it is not easy to calculate. I mean, to interpret. Calculation is okay, you can run an R script, I will tell you, but interpretation is more important, and then can be difficult. You can just Google climatic stream definition. Extreme definition. And you can just Google this climate indices. Let's see this. This is also, there's a lot of things you can do. You can click. This is one of them. Let's see. Normally I'm using this one. It is already open. You can just click on this and you will see. This is also okay. There is a link. You can click on this. Oh, this is about something about the workshops and this stuff. So this will give definitions, and then the variable that for which variable these extreme are. But I simplified this climatic stream in this file, the imsort file, and this file contains serial number, then the ID, indicator name, or the name, definition, and the units. Like this is the FD naught is frost days, number of frost days. This is the annual count when Tn. Remember that Tn is for minimum temperature in this context, and Tx is for maximum temperature. Remember this point. So annual count of days when daily minimum temperature is less than 0 degrees centigrade, and the unit is in days. This means that if D naught, suppose there is a value of if D naught is 5, this means that there are 5 days on which the minimum temperature is less than 0 degrees centigrade. And this, the summer days, issue 25, summer days, annual count of days when Tx or the maximum temperature is greater than 25 degrees centigrade. Let's suppose issue 25 has a value of 200. This means that at that particular location, there are 200 days in a year, in a given year, on which the maximum temperature was greater than 25 degrees centigrade. By the way, you can change this definition, but you need to implement this in R code so that you can calculate accordingly, because in some areas, this temperatures maybe not so high temperature. Similarly, there are other definitions of these extremes, like I would like to say TNN. Remember that TNN is for minimum temperature, and N, this means that minimum. So small n is minimum up T minimum temperature. This means that monthly or annual minimum value of daily minimum temperature. Monthly minimum or annual minimum value of daily minimum temperature. Similarly, you can explain Txx. Remember, this is the opposite to this. Tx is maximum temperature and x is also mix for maximum up to maximum. Monthly maximum or annual maximum value of daily maximum temperature. And this is the unit is in Celsius. And similarly here. So these are the definition of these extremes, 27 climatic extreme. Indices. Remember, this is important to know. Then you can interpret your result. Otherwise, it's difficult for you. You will get the values, but if you don't know about the units, the definition, then it's difficult to interpret the results. And now I will come to the data format, that what data type, data format you need for this climate extreme. One thing is about the definition, the units, and this, which I explained. The second thing is data format required for calculation. And the third thing is we will calculate these climate extreme in R or RStudio. Okay, just come to the data format. This is the folder which I have, and I will show you that how you can make the data for this. This is the data. Remember that you need daily data to calculate climate extreme and precipitation, maximum temperature, minimum temperature. Daily data. So this is year, month, day. PPT is for precipitation. Maximum temperature, max is for maximum temperature. Minimum is for minimum temperature. This is not mandatory. You can name this minimum temperature in full, and you can write this maximum temperature, and you can write precipitation here. So this row is not mandatory, not required in calculating climate extreme using R. So I just delete this. I will not save this file so that I preserve my data, and I will close this file. But before that, I need to save this in .txt format because the data format is in txt format is required. Okay, this is txt and save. As it has already exists, I need to save, replace it. So I will not save this so that my original data is reserved like this. Okay. And now I want to show you this data because this is the data which I will need as an input to our script. You can see that there is no, the names on the columns. This is the year, this is month, this is day, this is precipitation. Remember, precipitation is in millimeter, maximum temperature in Celsius, and minimum temperature in Celsius scale. And let's see where this 99 year ended. Okay, it's ended here. So 1979, not 1999, 1979. And 1979, 1231, and this is the data, and then 80, and the data is from 1979 to 2014. Remember, this is also important because you need to give the beginning and the ending date in the R code. Okay, this was about the data format. Now let's go to R script, that how we can calculate these climate extreme indices. This is the R code which I will run in the R and RStudio so that I can calculate these climate extreme. Okay. Maybe you know that we can source a script from R directly here. So this is the command you can use. Remember that this script is in the same folder, same directory. Therefore, I don't need to mention the path. If your file is not in the same directory or folder, you need to give the path as well. You can source here as well, or you can run this command. I will just tell you that how you can source here. Just go to code, source a file, and you need to navigate what you want to source. So I want to source this code, and you can see it is run. The same thing I will do. And the path is here, source the path until here, not here, until here. So this is something. So this is something like this. Okay. This is one way. The other way is to run this simple code because this is the source command. and the file is here in the same directory. Just run this from here. And when you run that, you will see you have this window. One thing, remember that there is no folder here. And when I run this R code, this, and put some parameter, you will see there will be some folder will create. Okay, let's go to this again, this one. There are three things: load data and run QC, quality control, indices calculation, and exit. So the first thing is load data and run QC. Okay, so this is the data. You need to navigate to the folder, but this is already the same folder. So just click on this. Okay, this is the indication that the data is in the correct format. And now I need data loaded. Click OK to continue. Okay, you don't need to do anything. Just click on OK. Okay, data QC may take a few minutes. Click OK to continue. Errors and temperature, please check the log file. Remember, these things are very important. There is error in the temperature. Check the log file. This is the path. And that the file name is tempqc.csv. Remember that I told there was no folder, but now there are 4 folders created. So, and remember these folders are empty now. Trend is empty. Plot is empty. Indices is empty. And there will be some file in log file. So the file name is tempqc, and they ask me to see this folder, this file, because there is some error. And what is the error? Remember, this is important. In 1981, month 7, July, day 16, and precipitation value is this, Tmax is this, T minimum is this, this is Tmax, this is T minimum, and this is the difference. So what is the problem? The problem is that Tmax should be higher than the T minimum. T minimum is 23 and Tmax is 0. This is wrong. So this is something which this R code tell you the quality, and that there are some problems in the data. This is obvious. Remember that T maximum should be greater than T minimum. If it is not this, then there is problem in the data. Similarly, 1986, 4th month and 5th day, again the maximum temperature, the minimum temperature is higher than the maximum temperature. And similarly for these two dates. So what you need to do, you need to do your data, you go to your data, Excel file, you need to do the changes and save the file again in the .txt format, and then run. Again, run from the start so that you have no problem with the data. This is important. Otherwise, there will be problem with your results. So remember this, you need to do this. This is important. Similarly, this will say some problem with the precipitation. Like, oh no, not the precipitation has no problem. There's some outlier in the data. This is also important. You need to adjust the outlier, some solution for the outlier, because for some methods you need to remove the outliers. So this is important. This is also the file name is mentioned, the path is mentioned. You need to go to that file and check and fix the problem. Click again. If you have checked, again, this say if you have checked, fix all these problems, then you need to click OK and go ahead. Okay. There's some problem with the OR. Okay. Let's run again. I need to do this all the things again because there was some problem. So this is my file. This was not source, not the data. You need to source the code actually. This is source. I need to source this R code. Okay. And now do the same steps again. This is the data. Not to do anything with this. Okay. Let's do it, try it again. Okay, let's see where's the problem. Okay, move this. Run it again. Okay. Data. Okay. The same as I explained, you need to do all these things. Okay. So there is no issue now. There was some problem, sometime it is restart. There are some time. So this step have been done, load data and run QC, and now I need to calculate indices. Remember that the data was from 1979 to 2014. So the beginning date and the end date. Okay, here. Nothing is happening. Why? Because in this script, you need to produce 1 year, I mean 1980, and reduce 1 year from here. 1 year from here is mean 2013. But this script will calculate for the whole duration, the indices for the whole duration. So you need to remember this, otherwise it will not work. Now click. Yes, it's working. So this is important. Now these are some extremes, the definition which you have seen here. This. So now you need to check if you need to calculate some specific climate indices, extreme indices, you need to check those and uncheck the others. And if you want to calculate all, you just don't need to uncheck and just click on this. And remember that now we have this folder, but I told you this folder are empty. Like I click this now. Not this one. This is log file. This one. This is empty. Just click on this now. Run this and you will see there will be some plots coming to there. Click. It may take more than 5 minutes to compute all these indices. So this is something. And when these indices are calculated, you will see a message. Just click and you will see now plots. Look, plots are coming. Similarly, in the other folder, other data is going. Now we have 11 items and this should be 29, something like this. It will take some time, so be patient. And let's check the other folder. We have some data in. Okay, there is one file. And there are 11 files. So 11 files and 11 plots. So this is coming now. Guys, it's taking some time to calculate. It's obvious, it is already mentioned. Okay, just wait some time, a few moments for this. And I will explain about these climate, the trends and these things. I will tell you about the different files and the analysis I will do in the next video, not in this because it will be too lengthy, so maybe it's not good. And if you like the content of this channel, please subscribe the channel. And you can write the comments. You can ask me the question about what we are doing. And if you have something in mind, you can tell me please in the comment section so that I can do that for you guys. If you have some misunderstanding or something like this, yes, please. Okay, now I hope the graphs, the plots will come now. Yeah, actually this depends on your machine, the configuration of your machine, that how much time it will take to calculate these, because this is calculating the plots. This is calculating the indices, some for monthly on monthly basis and some for on annual basis. They calculate all for annual basis on annual basis, but some of them are on monthly as well. So of course this take time, and the data is from 1979 to 2014. It's a long data, so of course it will take time. You will see the data when it is completed once. Yes, the plots are now coming. So yes, we have received this message, and this is calculation completed. Okay, and the directory is also given. Okay, just close this, and you have 29 plots. Let me just explain one or two of them. This is DTR. This is these are the data points. This is the trend line, and this is the slope of this line, and this is the p-value. So this means there, of course, this minus sign say that this is decreasing. This GTR is decreasing, and it is significantly decreasing, by the way, when this p-value is less than equal to 0.05 at 95% significance level. And let me check now the increasing one. This is TR20. You can go and you can see the definition, what is mean by this. These are the values, and the line, this is the slope 0.785, and the p-value is 0. This means that this is significantly increasing. So you can have a lot of information from this graph for each climatic stream indices. So this is about the plot. Now I want to show you about some other things. This show the trend in these climatic stream. For each climatic stream, the trend which you have saw there. So this is Tmax mean like this. Let's see TR20. Where is TR20 is this one? This is 0.785. This is the same thing which you saw in the plot. 0.785 is the slope. Check you again. This one, 0.785. Remember 0.785 for TR20. The same thing. So this is the slope. Or you can say the trend, as they call this trend, like this trend. So this is, and you can see for others. So this file have the trend, this have the indices, and this have the plot. So trend and indices are combined, and they created the plot. So I want to show you the indices as well. These are all these indices. The name is given at the end: CTD, consecutive dry days, CSDI, CWD, consecutive days, and all these things. So this is the DTR. These are on monthly basis and also on the annual basis. So you can do some calculation, whatever you want on monthly, on annual basis. I will explain that how we can analyze these extreme in the next video. So until here, what we have learned that what is climatic stream, their definition, their units, their names, and then what type of data format we need to calculate these climatic stream indices in R or R Studio. And then we calculated this climatic stream in R or R Studio. And we will analyze these climatic stream indices in the next video. So thank you very much for being here. And if you like the content, please subscribe the channel and write me if you have some, you want to know something more, or you have some problem or some misconception or something like this. Okay, thank you and see you in the next video. Ciao.